Hello, everybody. It's great to be here. How are we all feeling today? We good? Put your hands up if you're feeling okay. I want to make sure you can hear me. Who's listening to music on their phone at the moment? Okay. Yeah, okay, there's a couple there. So who was here last year? I did a talk here at this event last year. Does anyone remember that talk that I did? Came for that talk? So you're going to see a couple of familiar things there today. Was anyone at our Constellation event that we held here in Singapore in February? Did anybody go to that? Just want to get an idea of how many people I get to see more than once. Not too many. Okay, that's good. That's fine. So we're going to do a couple of things today. I'm going to talk briefly about what's new in GitHub Enterprise 2.13, which we actually released last Wednesday morning. It's brand spanking new. And in fact, it's so new that I couldn't get a list of all the features to pop in. So I'm only going to talk about a couple of them. But we are holding a webinar next week at 1 p.m. Singapore time. So if you come and see us on the stand, we'll give you the URL so you can register for that particular webinar. Then after that, we're going to go through this long title here. I'm going to go do a demonstration of how you can automate serverless deployments using GitHub.com, AWS Lambda, and AWS CodeStar. And this is basically a demonstration that's grown over time. We presented something very similar to this last year, but there was no CodeStar and there was no Lambda, but it's grown and grown and grown and grown. So we're going to take it through from there, and you're going to see how it's changed. So firstly, what's new in GitHub Enterprise 2.1.3? And my slides aren't carrying through. Hello? There we go. Cool, it's working now. Cool, so what's actually new now in GitHub Enterprise 2.1.3? And I want to talk about first about how we're actually helping the developer. And in those kinds of terms, I'm going to be talking about how you can collaborate much better in the process. So what we've done is we've introduced the concept of team discussions. You probably know that with issues and pull requests within GitHub, you can often have a conversation around the changes in your code or the bugs that you might be having to work on. But sometimes you might want to have discussions that aren't necessarily suitable to put into an issue or a pull request. So through that, we've brought in now the ability to have team discussions. Team discussions gives a place for your GitHub community, your team, to have discussions about anything that might be relevant to your projects. So here you can see a screenshot of a discussion that's based around our employee team, literally within GitHub itself. And we've had this available on github.com for a while, but we're finally bringing it into the enterprise version of our product. Another thing that we've been asked about is the ability to be able to recognize situations where multiple people are actually co-authoring a commit. It's not always just one person that's working on a particular piece of code. You want to be able to basically allow and let people know that it might be myself, it might be my partner Marisa or Sam, who have also worked on that code at any one time. So now you can literally mention another GitHub user as part of your commit message, and we will recognize the fact that they've been a co-author on that commit. That means that they get recognition through the pull request. It also means that their contribution graph is kept up to date, which is really, really important if you're using a contribution graph to look for another job. All right. So what else do you want we've brought into play here? I'm going to move away a little bit from the developer space and look into how we're extending the GitHub platform to make it a much better part of an overall ecosystem of development. So you can see here a couple of screenshots of issues and pull requests, and you'll notice that there's one little person there that keeps interacting. That person is there. It's like new PR, new issue welcome, and so forth, but they've got this little label next to them called bot. And that's because now that we've vastly improved the way that you can integrate other tools with GitHub, and we call it GitHub Apps. And the idea here is that you can install an application into your organization, or you can do it into your own user account. The good thing about it is that you basically can manage the permissions as if it was an individual user. It gets treated like an individual user. It gets audited by an individual user, but it doesn't actually impersonate the user. In other words, if I leave the organization, any of the applications I create still will work. And that's a problem right now if you're using an individual user account to build your CI pipeline. The other good thing about it is it doesn't actually take up a user license like we used to have to do before. So this is a vast improvement in the way that we can actually integrate GitHub with other services such as Travis, such as Circle, such as any of those tools that you use to build your software. We've got other changes as well, like I said, in terms of integrations. There's things like new APIs that are involved. There are new webhooks that we've brought into play. And like I said, we'll talk about those a little bit more in our webinar next week. I just want to cover off now how we're enabling administrators to be able to manage GitHub in a much better way that helps them. And one of the requests that we've had for those customers who are using GitHub is that even though they might integrate with a service like LDAP to provide external accounts to the GitHub instance, they still occasionally want to be able to create a direct account on GitHub. It might be an external contractor that you have in play, or it might be the fact that you don't actually have a GitHub app right now, but you want to create a quick machine account. We've enabled that to happen. So now you can go into the, to the administration screen and go down to the settings and click on the allow creation of external accounts with built-in authentication. And what that basically allows is if you're still using an LDAP directory to authenticate users, you can still use an internal account as well for those temporary cases that you want to be able to use an individual account. And once you've clicked the button, Save Settings, restarts everything and away you go. The other thing that we've brought into play as well is making pre-receive hooks a little bit easier to work with. If you don't know what pre-receive hooks are, they're a feature that we have on GitHub Enterprise that allows you to inspect Git data before it's pushed into the repository itself. You can enforce policies such as making sure that a new branch begins with the name, with the username of the user actually creating that branch. And if not, you can actually push back through Git protocols and make sure that the user fixes their mistake before it ends up inside the repository. But we discovered when we were going through the documentation of Git that there was a nice little option called -O or /push options. And what that allows you to do is to push additional strings to the GitHub to the Git server that allows for things like metadata. And we've decided to be able to support that as well. So if you now go into the GitHub pre-receive hooks documentation, you can see that now what we do is we take out those options that are passed as part of the Git push, and we actually present that to the GitHub pre-receive hook environment so that you can do things like start working with metadata around those pushes, so that you're not polluting your commit message or anything else with information you may not necessarily want to stay there. Now, we have 5 customers in the world that use clustering, but this is kind of going to be really important to them. Recently with GitHub Enterprise, we introduced the ability to hot patch your GitHub Enterprise environment without any downtime. So in other words, you can apply a patch and keep moving along, and users can still keep moving, working back and forth, pushing and pulling as they need to, without actually having to restart the server. One of the limitations was that for our customers with clusters, they couldn't do that. So with GitHub Enterprise 2.1.3, we now actively support hot patching for clusters as well. And the last thing I want to talk about GitHub Enterprise 2.13 that we've released is we've started to integrate Grafana into the monitor dashboard. And if you've used GitHub Enterprise up until now, you'll notice that our dashboards are relatively static. They're very difficult to see things and not necessarily easy to work with, and we wanted a much richer experience of working with it. So you can see here we have live resizing, live updates. We can do things like get a much richer interaction with those graphs. And so we've brought Grafana into play here, and we're going to do a lot more with this. This is a full Grafana integration. It's not just something we've plugged in. So we want to have the ability eventually to be able to do things like plug your own applications and plug your own metrics monitoring into the system. So the good thing about all this, as I said already, this is all available now in GitHub Enterprise 2.13. We released it last Wednesday, and that's enough for an update on GitHub for now. Like I said, we are going to do a webinar next Monday at 1 p.m. Singapore time, so please, everybody that's in here, come and hit our stand all at once. We love that, and we'll give you the URL so you can come and register for it. So let's talk about something a lot more interesting now. You're here at an AWS event, so let's talk about some AWS technologies. And what I want to do is talk about how you can automate serverless deployments using GitHub.com, AWS Lambda, and AWS CodeStar. Now, has anyone here actually used AWS CodeStar yet? Put up your hands if you've had a look at it. Does anyone know what it is? Cool, a couple of people do. So let's cover that off. What's AWS CodeStar? AWS CodeStar is a great cloud-based service that allows you to create, manage, and work with software development projects on AWS. It allows you to orchestrate everything you need to deploy your application. So for example, you might require S3 buckets. You may require an AWS Lambda function. Basically, it allows you by templates to describe the entire stack for your application and then be able to have the CodeStar go and build and deploy it. But it brings a whole bunch more other things into play as well. It integrates with repositories like GitHub, for example. It allows you to do things like build your complete build and pipeline. It gives you a dashboard where you can look at things like how many times has your Lambda function been accessed, and a whole bunch of other things as well. All right, so what does the architecture look like? You saw some great diagrams in that previous presentation. Hopefully I can live up to those. But obviously for us, it involves GitHub, because that's the way we would like it to be. That's where you keep all the source code for your applications. It's also where you keep your configuration templates, because now you can actually do a true developer or a DevOps mentality to your deployments. This really is infrastructure as code. Now, obviously, you have GitHub that stores all that code. And then you have AWS CodeStar, which is sitting in your region of choice. And basically, the way this works is something changes within GitHub. You've changed your template, you might have changed your Lambda function, and then we trigger that. We understand that there is a change. Once we understand that there is a change, we consume that change and we send a little message off to AWS CodeStar. CodeStar receives that message, comes back in, interacts with the GitHub repository and pulls everything down that's changed so we can go ahead now and start adding to your environment. Once it's done that, it figures out everything it needs and goes and builds those particular resources. So it can be something like, I said before, an S3 bucket or an AWS Lambda function. If you're just updating the Lambda function, then we'll go ahead and just update the Lambda function for you. If you've decided that you need another S3 bucket, it will go off and actually go and create that S3 bucket for you. So what does this look like getting started? Let's see what it's like to create an AWS CodeStar project from scratch. So there's a couple of things we're going to do during this demonstration. We're going to create an identity and access management user, because CodeStar likes you to log in as one of those. You cannot do this with a root account that you might normally work with. We're going to create the project in AWS CodeStar. I'm going to wander around the project a little bit so you get an idea of how it works and what it does. And then we'll make a quick change and we'll see how that change automatically flows through the whole process and deploys. Once we've done that, we're going to swap it out with our own code. And we're going to change totally the way the application runs and what it does so that you can see how easy it is to keep working on your code, on your application. So at that point there, we're going to clone it down to our laptop. We're going to create a role so that our Lambda function has access to both S3 buckets and some CloudWatch event logs. We also want to make sure that we reset our stack so that we've got a nice clean environment to begin with. Check and make sure that our project has the right permissions to create all the resources it needs, and then we're going to go and replace that code and build a whole new bunch of resources off those templates. So let's do that now. So I'm going to go in and create the identity and access management user, and I'm going to do this with my mind. I have mind control, those of you that have been to my processes before. So here I am, and I'm creating my user inside of the IAM console. It's management console access, so I'm going to give it a custom password, and I'm going to make sure that I don't need to change the password next time I log in. I'm going to give it the permissions to access S3 buckets, AWS Lambda, as well as AWS CodeStar. So what I've done now is I've created a user that has permission to go and create everything I need to begin with. I take a copy of this little URL here because that gives me the custom console I can use to log in at. So here is our user. And we've created our user. So the next thing I want to do now is do the meaty stuff. I want to actually now go in and create that project within CodeStar. So let's do that. So I have to log out as the user I'm in and log in as that user that we just created. So I'm logging out now. We're going to our custom console and logging in as that account that I just created. And here you can see now I go into the CodeStar and you can see I haven't created a project yet. So let's start a project. There is a filter for the type of project I'm looking for, which happens to be Node.js. And I also want it to run as Lambda, so I can go and select that one. So that first one is the one I want, and I give it the name Create Thumbs Lambda because we're going to use that later. Right now I'm going to tell it there are repositories in GitHub. So I click that button and it just makes sure that I authorize AWS CodeStar to now go and create that repository on GitHub, and we're going to do that now. It's connected. I decide that I want to keep it in an organization so I can work with other people, and may keep it private because I'm not ready to give it to the world. I click on Create Project, and it gives me a couple of hints as to how I can actually now go and connect to that source code repository. I'm going to skip that, and I'm going to click on the next button as well to say that I've already done that connection. Now this takes a while, so I've sped this up. So it's probably a good idea now to go get a cup of tea or grab a cup of coffee, whatever's good, because that will take a few minutes, but I just wanted to spin through that. And we've now created our project. So let's have a look at that project and see what we get out of it. So as we scroll down, we can see on the left-hand side, we get access to a wiki where you can create documentation for your new users or anything else that you want to document. On the right, we have an application endpoint, and if I click on that, we can see our web page that we just generated. Further down on the left, we now have an integration directly with GitHub where we can see the commit history on the master branch. And I can look at other branches if I need to from there. On the right-hand side, we have our continuous build pipeline that uses things like code deploy, code build, and CloudFormation. We have our application activity dashboard there where we can see how many times the actual Lambda function has been called. And here we have a direct integration with GitHub that shows all the issues and pull requests that are available from that particular repository. I can filter them by open, closed, or by the user. There's a link to go to GitHub directly, or I can just go in and create an issue, and it takes me directly to the repository in GitHub that it created. So let's create that issue. And if you can see now, we can look at the code that it actually created as part of the project. It's got lots of notes, lots of great documentation for you to have a look at so that you can get up and running and make all the changes you need for your application. Down the side, we get to navigate through things like our code build history, our projects that we've got going. You can see now that we can look at our deploy, so we can look at our stack and what was deployed and when that was deployed. And we can also look at the pipeline. And the pipeline allows us to actually go and view and edit the processes and the steps that were made to create our environment. And you can also see that our issue that we just created a few moments ago is now sitting in that list there too. So CodeStar is a great way to collect all those resources together to give you that single dashboard of your entire deployment and lifecycle. All right. So let's now commit a small code change and we'll see how that affects our deployment. So I'm going to go into GitHub now, and I'm just going to scroll through to some JavaScript, and it's the JavaScript that generates that background gradient on the page. And you can see it changes depending on the hour of the day. I don't like that. I'm going to keep it so it always looks like what it would look like at 10 a.m. So I'm just going to copy that code and change it to a much more static string so that we're using a single class name. I commit it because I'm a good developer with a message, click on commit changes, and if I flip back in, it's already started to deploy. So it's grabbing the changes to the source code. It'll go down now and build any packages or grab anything it needs. It then goes and figures out what the infrastructure changes look like, and then we'll go and deploy them. Once that's done, which is there, we scroll up, click on our application endpoint, and we can see now that our app's changed, and we get that blue background. So we know our infrastructure works. We know now that when we make a change in GitHub, they will automatically be reflected in our deployment within AWS CodeStar. So let's use our code. Let's make it a little bit more complex. So what do we want to do? Well, we want to have a Lambda function that will take an image that we put in one S3 bucket, resize it, and put it into another S3 bucket. So this is a photo I took on my holiday to Japan a few weeks ago. And basically, I want to have it so that any user can drop an image into one S3 bucket. It lets Lambda know through CloudWatch. Lambda grabs a copy of that image, resizes it, and pushes it into another S3 bucket. And then at any point in time, the user can grab that resized image. Right? Pretty straightforward. I'm going to change the world with this application. Our architecture, as we covered before, basically looks like this. All our templates, all our source code, all of that sits within GitHub. It messages AWS CodeStar whenever any changes are made, and then CodeStar takes over from there to ensure that our deployment environment is up to date. So what we're going to do now is we're going to clone that project locally onto our development system. We're going to create a special Lambda role for the Lambda function to work as, because we need to give that Lambda function permission to both access the S3 buckets as well as the CloudWatch event logs. So it can actually go and react to when somebody puts a file into that bucket. Once we can do that, we're going to clean up the existing stack that we created. The way CodeStar works is that it generates a change set based on what the environment looks like right now. And because we're changing our application entirely, it's probably a good idea to clean out all the old stuff out and start again from scratch. We're going to make sure that the CodeStar project has the permissions to be able to go and create the S3 buckets that are required, as well as the Lambda function, as well as be able to give the Lambda function the permissions to access the S3 buckets that we're creating. Then we're going to replace the code and watch what happens from there on in. So I'm going to clone it and open it in Atom. So here we are in GitHub again. And I go to our favorite green button, and I can clone either using SSH or HTTP or download a zip. But I'm going to open this in GitHub Desktop, which is our Electron-based visual Git tool. So I've now downloaded and cloned it to my laptop, and I can open it locally in my development environment. So I'm going to use Atom, which is our text editor. And this is the Lambda function as it exists right now. It basically grabs an index HTML file that's sitting within the structure and throws it down to the web browser. Because it sends it down as a text/HTML MIME type, then the web browser knows it's got to go and display that within the browser and grab all the associated JavaScript and so forth. That's very different to what we're going to do with it. All right, so that's our current project sitting within Atom. Next thing we're going to do is create our identity and access management role so that we can give our Lambda function permissions to go and access the S3 bucket and go put files into a different S3 bucket. So let's do that now. Here I am back in our IAM console, and I go to roles and I go create new role. It's an AWS service and it's Lambda. So I select those things and click on next. Again, I wanted to give access to the S3 bucket, so I'm going to go S3 full. In my demo recording, I picked Lambda as well. I didn't need to do that, but I didn't realize until it was too late. And then obviously CloudWatch for the event logs. I give the role a name and click on create role. So our role has now been created. All right, that's what we're going to use to give the Lambda function permissions to do the work it needs to do. Next thing we want to do is just capture some of those resource details so that we can put it into our template so that we can generate the right environment. So back here, I'm going to go into our role again, and I'm just going to click on the little copy button next to the role resource identifier and copy it into a little scratch file that I have. I'm going to do the same thing for the Lambda function because I want to keep the name of the Lambda function. So I also copy that into my little scratch file that we keep for later on. And we're going to use that to replace some templated stuff that I've got in our template file later on. All right. Next thing I want to do is clean up those existing stacks. By cleaning up the existing stacks, we're making sure that there's no weird behavior that's coming over from our earlier version of the Lambda function, which happened to be a web page. So I'm going in now into our CodeStar, and I'm just scrolling down to our pipeline and going to our CloudFormation dashboard. Just going to pick that first stack on the list and delete it. And that's going to get rid of the Lambda function, and it's going to get rid of a couple of other resources that we created at the time. The other thing I'm going to do is when we create the templated, the original version of the project, it throws a parameter to the CloudFormation system, which we don't use anymore. And if we don't use that parameter, CloudFormation will not go and deploy because it thinks there's an error. So I've cleaned that out. Excuse me. All right. And it's all done. Next thing I want to do is just revise our permissions. What I want to do is make sure that the AWS CodeStar environment has the ability and the permissions to create those S3 buckets because we didn't give it that ability before. So here I am, and I'm going back down into our pipeline, and there is a particular role that is created when I create the CodeStar project. So I'm just grabbing a copy of that and moving back into our identity and access management console. I find that particular role, and I'm going to go in and edit it. And I'm going to give it the ability to do everything with an S3 bucket, which it didn't have before. So I'm going to use the visual editor for this and just change those actions to include everything. The next thing I want to do is I need to be able to give it the ability to assign that role to the Lambda function that gives it the permissions to do what it needs to do. So you can see here I'm doing this via JSON, that's the pass role. And I'm just quickly copying one of the lines that's in our array there to make sure I get my names right. And I'm just going to copy that resource identifier for that role and paste it in at the appropriate space. So what I've done now is I'm giving this particular role the permission to assign another set of permissions to our Lambda function. Don't worry, this is really, really important. It may seem complicated, but this is one of the winning things about AWS, about how security and how permissions reliant it actually is. I think it's a great way of doing things. I click on Save Changes, and I've set everything up the way I need it to run. All right, so I've done everything on the infrastructure side. Let's go and create our code. So here is the template file we have at the moment. And you can see it doesn't do much. All it literally does is it executes one function that throws the web page back down to the user. Ooh, sorry. I went a bit too far there. All right. And so what I should get now is a video playing, which seems like it's decided not to play. So let's just wait there for a bit. Can we swap? Is there a chance we can swap a video here? It's decided to not play. All right. This is fun. Is there any way we can try and invoke that manually? Ah, there we go. Yep, there's a play button down the bottom there. It's the first time I've had a demo video fail on me. That's awesome. Ah, there we go. All right, so this is what our project looks like actually on the desktop. I actually have created a different project, which are these files here. And if I open up the template in that particular project, you can see here that we do things like we define our buckets, we define the permissions on the buckets that we're going to create, we define the resize function that we're going to use for that image, as well as the permissions that are required to be able to execute that. You can see I've got function name and role there that are just templated versions at the moment. And what we're going to do is just replace those with the names that we copied before to keep this going. All right. So let's do that now. There we go. I'm going to take a copy of those files. I'm going to go back to our original project, delete what we've got there, and paste these in. I've now opened up the template that's in the new copy of the project. Scroll down to that area, and I'm going to replace the function name and the role name with the information that we copied earlier. And that basically creates the entire infrastructure then that we need to be able to deploy this application. Excellent. So that's done. We save that. If I go back into GitHub Desktop, we can see that we've got our changes there, which, because we're good developers, we commit with a message, push it up to the server, and see what happens from there on in. So I'm now going to switch back into the AWS CodeStar, and we can see already it's grabbed the changes and starting to deploy them. So as we scroll through, we can see that it's now building the packages that are required for deployment. It's now generating the change set, and it's rebuilding all the infrastructure that we need before. So here we are in our S3, and we have our two buckets. We have a resize bucket that's currently empty, and we also have the actual original bucket that's also empty. So let's drop a file into there. Here is an image that's 1920 by 1200. Drop it in there, click through on permissions. Our image is uploaded. If we go back now and have a look at our resize bucket, we can see now that an image has been created in there, which I'll download and we'll open it up. And that's been resized. So now our Lambda function actually works. So that's basically it. We have now deployed a complete application using AWS CodeStar, GitHub, and AWS Lambda. So now what? Well, now that you have your code sitting in GitHub, you can do the usual things that you do as developers. You can branch, so you can do things like testing different infrastructure environments. You can deploy to Lambda test environments to make sure your code works the way you want it to work. You can do things like protected branches to make sure that people can't merge code into your master branch until you've gone through a pull request process, a code review process, and all those other things that people love to do on GitHub. You can publish that application as open source. I told you I'm going to change the world with this image resizing application. You can collaborate with others, right? Collaborate, bring more people in, bring more people, new, fresh ideas. And there's so much more you can do with GitHub. So for more info, thank you very much. This is almost the end. But for more info about the GitHub release, obviously go to our release notes that are available here. For Node.js, which is what our Lambda function is based on, go and check out the Node.js documentation. That resizing was using ImageMagick, so go and check that out as well. Plenty of great documentation around CodeStar and Lambda is available on the Amazon sites. So thank you very much, everyone, and have a great afternoon.